In this video, we're going to be doing a simple demo with the LEDs. So we're going to be able to turn an LED on and off using the feather. So before we jump into the feather part, this is a circuit diagram of the circuit we're trying to make. We have a voltage source, we have LEDs, and that's what the symbol is. And we also have a resistor that is in series with the rest of the devices. Something to be aware of is the circuit on the left and on the right are actually the same. It doesn't matter whether the resistor is placed before or after the LED. The current that flows through the resistor and through the LED is the same in either case. So in terms of what an LED looks like, we have both a positive lead and a negative lead. The longer lead is the positive one, and the shorter one is the negative one. Also, sometimes on the side of the negative lead, you'll see a flat spot with some LEDs. So that's something to keep your eye out for. Just if you notice it, it's good for verifying that that you've connected it correctly. The reason this matters is because the direction in which it's wired matters. Because this is a diode, current only can flow through one direction. So if you wire it in the opposite order, it might not turn on. Something to be aware of: never connect an LED in series with a voltage source without a resistor. So if you do that, then too much current flows through the LED and it will fry the LED, and the LED won't be functional. So make sure you're always using a resistor. Again, it doesn't matter where you place the resistor, but make sure there is it. It doesn't matter whether it's before or after the LED, but make sure relative to the voltage source, but make sure that there is a resistor. So I've opened up this program called Fritzing, and this is, you don't have to install this. I've just added this for demonstration purposes to show you how to wire this. So we have a few components already laid out on this breadboard. First, we have the LED up here. I have a resistor here. I have the feather M4 here. And you should attach these components just like you see it in the image. So if we remember how a breadboard works, you'll remember that essentially all of these, in this orientation, I suppose it's the columns, but essentially what's going on is these are all connected to each other, these are all connected to each other, these are all connected to each other, and so on. And then when we look at the feather, you'll notice that each of these pins are connected to their respective columns. This is really useful because we can add a wire between components or between pins and the components, as we'll see in a minute. Yeah. So in terms of how to attach this, make sure that you're using I believe they already came soldered on. You'll have headers that are soldered onto the feather, and those should go in pretty nicely on the breadboard. Another thing to note is that make sure that your micro USB cable, or the port for the micro USB cable, is facing outwards so that it's easy to connect to it when you need to download a program onto the feather. If this was facing in the opposite direction, you could imagine it's difficult to connect the cable because these components are blocking it. Great, so now that we have that out of the way, what we're gonna do is we're actually going to treat one of the pins as our sort of voltage source for this LED, and we'll use the pin to control whether there's current flowing through the Arduino or not. Sorry, through the LED or not. Notice I've connected the positive side of the LED, the positive lead of the LED to this side of the resistor, and that the negative side is in this column. We can tell that's the case based on the length of each of the leads. So now we're going to connect pin 5, and we're going to use pin 5 to control this LED. We can actually use any pin. We're just using this arbitrarily. So what we're going to have to do is connect pin 5 to one end of the resistor, just like that. And now this side of, essentially pin 5 is connected to this point on the resistor through the wire. Next, so before that next point, you'll notice that the resistor's direction doesn't actually matter. So if this was oriented in the opposite direction, so if I turn this 180 degrees, it won't actually change its function. It'll be completely fine in either direction, unlike a diode where the direction matters. So now we've connected the other end of the resistor to the LED, to the positive lead of the LED. What we have to do is connect the negative lead to ground. And the way we're actually going to use these sides of the breadboard to do that. So I'm going to connect, you can see the yellow highlighted region, those are all connected to each other. I'm going to connect this wire to this row. And this row, you'll see that the green highlights, if I click on one of them, everything that's yellow, those are all connected to each other. So something that's common to do is to connect these edges of the board to the power or to the voltage source. So what we're going to do is we want this to connect to ground because it's connected to the negative lead of the LED. And this isn't really relevant right now because we're using the pin 5 as our sort of positive voltage, but we can make this other row down here that's now highlighted. We can place that at a positive voltage. So what we're going to do first is go on the other side of the board and do the same thing on this side of the board by connecting the 3 volt to this first row, and these are all connected now. And this is a 3 volt. We can use this as an output, and then connecting the ground of the feather to the other column. Sorry, to the other row. So these, now everything in yellow here is connected to each other and is at ground. They're all connected to ground. Then this other row, this other row is connected to 3 volts. So if I wire anything to this row, it'll be connected to the 3 volt, to the 3 volt pin of the feather. Now, we still haven't connected this LED or the other edge to ground or to positive voltage, so we can do that by wiring the 2 columns to each other, the 2 rows on either edge of the board to each other. So I'm going to take a wire, that's going to be our negative edge, and I'm going to connect that here. So if you remember, this is our negative lead. This connects to this row, and then this wire connects us to the ground on the feather. And I can click this and you'll see the highlights that indicate that there is a connection between the negative lead of the LED and the ground of the feather. Next, this isn't relevant right now because we're, like I said, we're using the pin 5 as our positive voltage, but I can actually do the exact same thing that we did for ground for this other edge of the board and attach a wire between one edge to the other. And now this whole bottom row is connected to that top row, which is in turn connected to 3 volts. So I can attach some other load or some other device to 3 volts by connecting it to one of these rows. This is more convenient when you're working with more devices and whatnot, but this is something good to be aware of now. Cool, and that's pretty much it for our simple LED circuit, and we're going to jump right into the code now. So once you're done with wiring everything, jump into the Arduino IDE, and you'll see this blank sketch. What we're first going to have to do is declare what pin the LED is connected to. So I'm going to make an integer variable, call it LED pin, and set the value to 5. This is good practice because it allows us to change the pin number in case we want to wire the LED somewhere else in the future. So make sure you declare the pin number as opposed to manually putting the pin number in the future functions that we use. Once you've done that, so we're going to set up the serial monitor and using the 9600 value again as our rate. This will allow us to print messages as we turn the LED on and off. Next, we want to declare that at that particular pin where the LED is connected, we want to tell the feather that we're outputting a value from that pin and that it's not an input. So to do that, in the setup, we call pin mode, and we give it both the pin number and whether it's an input or an output. In this case, it's an output. So go ahead and type that. This all happens in setup. Now we're going to actually go through the loop, which we'll be repeating forever. In order to control what the voltage at the pin is, we're going to use the digital write function. We identify what pin we want to change the voltage of, and then set it to either high or low. The value of high or low will differ based on the board you're using. It's generally either 3.3 volts or 5 volts. And there's also low. When something is low, it's essentially at ground. So 0 volts. Yeah, so in this case, we're setting it to high. And because if we look back in the diagram, if the negative lead is connected to ground, and then pin 5 is connected to high, so whatever the voltage is, I'm assuming is 3 volts or 3.3 volts on the feather, that will be the voltage at 5, and therefore at this point in the resistor, and then the voltage at the negative lead will be 0. There's some math involved there's some voltage drop across this resistor. We're not going to get into that, but the point being is that there's going to be some non-zero voltage drop across the LED, and therefore, since the LED is wired correctly, the LED will turn on. Yeah. Now, if 5 was at 0 volts and the negative lead was connected to 0 volts or to ground, in that case, we're actually not going to see anything turn on because there's no voltage drop across the LED. So that's essentially the logic that guides how we're using digital write in this case. So first, we're setting it to high to some positive voltage, causing the LED to turn on. Then we're going to set, again, LED pin, but this time to low, at which point there will be no voltage drop across the LED and it will turn on. So the first statement essentially turns it on. The second statement essentially turns the LED off. And we can place a delay again in milliseconds. So I'm going to add a 2000 millisecond delay for about 2 seconds after each of these operations. And so this way it'll turn on for 2 seconds, turn off for 2 seconds, and then just keep repeating forever. We can also print messages like we did last time. So I'll say LED is on at this point because digital write, we write high to that pin. Then in the other, after the other statement, we can say that the LED is off. Once you're done writing this, we can compile. Make sure that we didn't forget anything. So the check mark button will compile, it won't actually upload, but the upload both compiles and uploads. The compile button is, or the verify, I suppose, the verify button is basically useful to check if you made some mistake in the code. And that's useful to find out whether this is an issue with uploading it or whether it's an issue with compiling it because you made some typo or there's a mistake. So that's the difference between verify and upload. So it seems this finished compiling and you should upload it. I'm not going to demo this on the Teensy, but if you have wired everything correctly, you should see the LED blinking on and blinking off every with a 2 second interval in between those operations. Once that's working, we're going to go into a slightly more advanced example of how to turn the LED on and off. So one of the limitations of the circuit that we designed with the LED is that the amount of current that goes through, that's outputted from the Arduino pin, or the feather pin in this case, is only about 20 or 30 milliamps. And oftentimes you'll be working with devices that require far more than 20 or 30 milliamps of current. That being said, we can still use the Arduino pin, just not in the exact same way that we had done previously. So essentially, we're going to add an N-Channel MOSFET, and this acts as our switch, and we can connect the device, in this case the LED, to some other voltage source or some other power source. And this allows us to have larger currents pass through our device. The Arduino pin still controls whether that switch is on or off, essentially, so it controls whether we turn the device on or off, but it's not providing the current is not coming from the pin itself. And you can see what I've drawn here, so we can assume this is some sort of voltage source, a resistor again, an LED, and we've added the N-channel MOSFET. Notice that the drain connects to the resistor and LED, and the source connects to the ground of the voltage source. And the gate is controlled by pin 5 in this case. So pin 5 controls whether the drain and the source are connected to each other. So again, make sure you double check what your N-channel MOSFET looks like. I'll be using this example. I believe some people might have received a different one. So make sure you look up the part number and check the data sheet like I had shown in the previous video to make sure that you're connecting these pins to the right places. I'll be assuming these connections when I'm demoing it and fritzing, but you need to double check to make sure that each of these pins is connected to what you think it's connected to. So this might differ for you, and make sure you double check that you're connecting things to the right point. I'll be assuming that this is the orientation. So it's open fritzing, and I've added the N-Channel MOSFET. So I'm gonna throw this onto the breadboard. And if we go back, so the first thing we'll notice is that the drain is going to correspond to this rightmost lead. The gate, which is going to be connected to pin 5, is in the middle, and then the source is going to be connected to ground, which is what we showed in the previous slide. So what we're going to do is I'm going to wire, so in the previous demonstration, we connected these edges to each other, and we have a row with the ground and a row with a positive voltage, 3-volt voltage. So we're going to connect first we're going to connect the source to ground, and we can do that by connecting a wire to ground, and that would be this second row. So if I click on this just so you can see, we can see that the left part of the transistor is now connected to ground. Cool. Next, the gate is going to be this middle part. The gate is going to be controlled by pin 5 of the Arduino, or the feather in this case. And to do that, we're just going to connect pin 5 directly to the gate. So this will be what controls the gate. And this might not be clear, but this wire is only connected to the column with the gate and to nothing else. This is a bit more clear now. Once we've done that, now we actually have to add the load, which would be the LED and the resistor. So I'm going to drag the LED onto here. I'm going to drag the resistor onto here, connecting one end of the resistor to the positive lead of the LED. And so now we have our load, which is the resistor and the LED, but they're not connected to any power. So the first thing I'm going to do is connect this end of the resistor that's not connected to the positive lead of the LED to the plus 3-volt row at the bottom here. So you'll see this is all connected to plus 3 volts here. You could also use an external, don't do this for this example, but for future projects, you could be using an external voltage source. But for the sake of simplicity, we're actually just going to use the 3 volts provided by the feather. So we're going to connect the positive 3 volts to one end of the resistor. The other end of the resistor is connected to the positive lead of the LED. And then we want to connect the negative end of the LED to the drain part of the MOSFET. So essentially what's going to happen now is that we have a 3-volt voltage here, but unless this end is connected, unless the negative lead is connected to ground, the LED won't turn on. As soon as the negative lead is connected to ground, the LED will turn on because there's going to be a voltage drop across the LED. So essentially what's happening here is that we have this MOSFET acts as a switch that connects the negative lead to ground only when pin 5 is set to high, or in other words, the gate is set to high. The gate is low, then the negative lead is not connected to ground and the LED won't turn on. So in terms of what the code looks like, it's actually going to be identical to the code that we wrote for the other module, or with the direct connection of the LED to pin 5. Because again, we're just setting pin 5 to high to turn it on and pin 5 to low to turn it off. So the code stays the same. So another example with the LED circuit is to use a P-channel MOSFET. We won't actually be doing this because I don't think we sent you a P-channel MOSFET. But the way that this would work is that you would connect the source to this positive voltage, then connect the drain to our resistor and LED in series with each other. So this would be our load. And then our load then connects to the ground of the battery. So in addition to that, the difference is how this gate controls whether the source and the drain are connected. So if the gate voltage is low, then the source and the drain will be connected. And if the gate voltage is high, the source and the drain are not connected. So again, this acts as a switch, but the difference between the P-channel MOSFET that we're looking at and the enhancement type N-channel MOSFET is that the gate, the way the gate controls the connection is different. And the second difference is that with the P-channel MOSFET, we connect the source to the positive voltage. And with the N-channel, the enhancement type N-channel MOSFET, we connect the source to ground. P-channel MOSFETs might come in handy in the future, so we wanted to mention it here. That's the end of this module.